All right, well, welcome to the PyWeb Meetup. This is our first time trying this venue out, so it sounds like people want food during the meetup, so maybe we'll be somewhere next month. But just a couple announcements before we get started. We have Texas coming up in September, end of September, so if you want to learn some more Python stuff, it's in College Station over a weekend. Check out pytexas.org and registration's open. It's pretty good conference and not too far away. So check that out. Also for the meetup site, this is all volunteer, and we have some fees and stuff that we have to pay for the meetup site. So if anyone wants to ever chip in, there's a chip in button. You can donate a few dollars. The fees are due this month, so we'll be paying that this month. And then I guess for our talk tonight, we have Nick, who's going to talk about Django Secure.
Yep.
So, and I guess since people, if anyone wants food, maybe we'll all head over and get some food and beer at the Black Labrador afterwards. So we'll head a party up over there afterwards. So I'll turn it over to Nick.
Okay.
Keep us secure for the night.
Yeah, that's right. So I actually I read the abstract for my talk, which of course I wrote before I wrote the talk, and it's a complete lie. Everything it says to you there is just bogus. So anyway, I wanted to show you. We've been at my work. We've been doing a lot of cloud services, and all the companies that we work for are wanting to know that when they give us data, we're going to keep it secure. And so I'm going to show you one aspect of that. And what I'm giving you here should allow you to pass a rigorous security audit by a major firm. Okay, so if you manage to take this in, and I'm gonna make you guys tap today, I think. You're going to be unhappy by the end of this. This is not going to be a whole lot of fun towards the end. But this is not going to... When they do these security audits, they also want to know that the actual server is secure, and they want password management, and they want to know that you don't have rootkits on your machine. I'm not going to talk about any of that. It's out of the scope, so... Just because you've encrypted things on the wire does not mean that you've got good security. So you can look elsewhere. And oh yeah, I've gotta say, this whole talk and the code here can be found on my GitHub, which is Nick Thompson. I think actually it should be. I'll show you in this thing. So there's the GitHub link. And this is how I set it up when I get going here. You clone it, you stuff a virtual environment on top of it, and install the requirements. And for this talk, we gotta acquire a root shell because we're gonna be opening up privileged ports. Okay.
You have slides on GitHub.
Yeah. This whole PDF is on GitHub, and as well as the code. So this is the stack that I use. It's just Django, Green Unicorn, Nginx. And so I'll show you guys how to securitize that configuration. But the concepts are very similar if you're using Apache. Once you know the concept, getting the Apache config the same will be very easy for you. Okay. And just to give you some background, Green Unicorn is this Python web server gateway interface, and basically it just allows Python to do a lot of work and then be passed up the stack into Nginx. And you can actually serve your website with Green Unicorn, but they say don't do that because you'll get knocked over by script kiddies. So this talk was ostensibly about Django Secure, and but what I found out is that you can do this either in Nginx or in Django Secure, most of it, and Nginx is faster. So we're going to talk a lot about Nginx, about how to serve that. configuration. You've got for kind of a gotcha, when you're using this Django secure package, their settings will override the Nginx settings, or it will set headers twice. It's very bizarre. So try and use one or the other in your actual stack. And so if you're going to use this Django secure, if you know about Django, you have this installed apps, you put this SSL server and Django secure there, and you can run this code to check the security, and then for development, you can run this SSL server. And then you can use your self-signed certificates when you're developing without worrying about how HTTPS is going to affect your actual site. Okay. And then this is how you install Nginx. It's not rocket science. And when we're listening on port 443, we're going to pass it to Green Unicorn, which is going to be running on 127.0.0.1. Okay. So this is just going to use Nginx as a reverse proxy. We're going to pass it down to Green Unicorn. And then this is how you actually start the server. So I'll show you how to do that over here. Those who want to follow along can. I'll exit out of this root shell here. So we need to acquire a root shell, and then source our paths. And then when we go ahead and start up Green Unicorn, actually I've already started it. The command is, let's see if I can find. Here's the command to start Green Unicorn. It looks in this config, and then it starts this application, which is HTTPS. And it's just a very, and then once we're done starting that up, we start Nginx with Nginx -C, and then reload it. And if you go to this website, which I've got up here, it just says hello world. Okay, it's just easy stuff. All right. Now, Nginx comes with a default configuration, and if you go to a website called SSL Labs, have any of you heard of SSL Labs? SSL Labs does security audits for people, and they also have a nice little tool online that will check your website for security. And so basically, if you run the default configuration, SSL Labs will give you a B. It doesn't think it's a very secure configuration, and we'll go into why that is. But you can follow this link here, and we can try. I mean, if you try your bank, it's generally going to horrify you because.
You can try pytexas.org.
Well, let's try pytexas.org. Let's see how good pytexas is.
Yeah, how good my security is.
Yeah. It's actually a very expensive computation, I guess. So what it's showing here is that PyTexas has signed their own key with RSA using a 24-bit key, a 2048-bit key, which is pretty much fine. Then we've got the certificates through Komodo. It's showing your whole chain here. Oh man. So it actually takes quite a while because it's doing a handshake with every protocol that it knows about. So once it's done, oh my God. We'll come back. Okay, so if your clients have an IT policy, they're not going to be happy about seeing this, and they're going to want to know that you're going to do something about it. So the first thing that I did when I was doing this is I removed support for TLS v1. Okay, and I removed support for TLS v11 as well. Do you guys know what TLS is? So in the early 90s, there was a lot of crypto systems out there, and they were all kind of hand-rolled, and some of them had patents on them, some of them didn't. And this browser couldn't talk to this server because they didn't know what cipher suites that they were going to be using. They didn't know how this was encrypted, and they couldn't talk to each other. So they decided to start standardizing them in these protocols called SSL. So that was Secure Sockets Layer. That has been deprecated and been replaced by transport layer security, which is the new TLS. It's not all that new. TLS 1.2 is now, it was 2008, I think. And so you can be pretty happy. So TLS version 1 came out in like 1999. TLS 1.1, 2006, and TLS 1.2 was 2008. TLS version 1 is basically broken completely. SSL is completely done. But still, if you decide to remove support for TLS v1, these old Internet Explorer browsers won't know how to communicate with your server anymore. And there will not be an informative error message when they go to your site either. It will just be connection refused. So if you do this, if you're running Facebook, you're not going to do this, right? If you're running a data server, this is probably a good idea.
Do you know which version of IE is that?
Yeah, and
7?
I'll show you. There's maybe we've gone through 400 seconds now. Okay, so pytexas.org. He gets a B. Oh no. So you can tell what versions are supported by this thing called handshake simulation. Okay, so SSL Labs will go through every version, every basically browser it knows about, and it will see what sort of security that your server will interact with that browser with. So for PyTexas, it's going to use TLS Android 2.3, is going to use TLS 1.1. It's going to use transaction or transport layer security with Diffie-Hellman key exchange and RSA for authentication and triple DES for encryption. It's triple DES is like 1994 or something like this. This is pretty old here. But if you go to like Chrome, it's going to use elliptic curve Diffie-Hellman exchange. And as you can see, even if you enable TLS 1.0, you're going to lose Internet Explorer 6. Which, I mean, these people kind of need to upgrade their browser. but still. So yeah, this is a handshake negotiation. You'll probably want to look at it if you have like kind of, how would you say, customers that don't have data security requirements, right? You want to maybe open it up a little bit more.
Is that just saying the old version of Android is not going to work on TLS 1.2?
Yeah. So
you're blasting out everything behind 4.3?
Okay, so like actually, let's go into this a little bit deeper. So I'll show you. Let's see. I'll show you the one that I've set up here, and I hope that it has it cached. This is just a kind of a ridiculous domain that I bought for this test. And it looks like it did not cache the query here. But we'll come back to this we'll come back to that question in just a second. Okay. So I want to give you some reasons for only supporting TLS 1.2 if you have customers that actually care about their data. If you've got like a read-only website, I would just encrypt it and maybe try and expand the number of devices that can access it. But if you're taking users' data that they value, or you're taking payment cards, then pretty much you got to get rid of TLS version 1. And a lot of these consortiums are saying you're really kind of taking a risk by using TLS1. And since TLS 1.1 came out, since TLS 1.2 came out so fast after TLS 1.1, there's basically no browsers that implemented it. So you might as well just get rid of TLS 1.1 and TLS 1.0. Okay. And to go back to Glenn's, so when I say, you can see that I've disabled support for TLS 1.0, and that lost me Android 2, 4, 4.1, 4.2, and 4.3. Basically only 4.4 is now supported. So when anybody accesses my website from Android 4.2, they're not going to get any error message. It's just going to be connection refused. They will not know what happened. Okay. You can also see that Baidu is not supporting TLS 1.2. I don't expect the Chinese government to allow them to support strong cryptography in any time in the near future. So basically your Chinese are going to have to start using an American browser. And here you can see what Internet Explorer browsers you lose by doing that as well. So basically you get IE11, and that's about it. And Java, no Java. Thank God you don't have any Java clients coming onto your website, right? All right. So when you go into SSL Labs, if your customers know about SSL Labs, they want to see a nice grade. And one thing that SSL Labs believes is that 256-bit bulk encryption is better than 128. Okay. So just to get a feel, you guys know about the difference between like the public key and the symmetric key protocols. Basically your public key are a lot slower. They're using these gigantic key lengths, whereas your symmetric keys are a lot more secure with smaller key lengths. Okay, so the symmetric protocols, SSL Labs thinks that they need to be 256 bits. And so what you're going to do to get your grade up is restrict the supported cipher suites in the Nginx configuration. And so here's what you're going to put in your Nginx conf. Okay? And this is a total mess, so I want to show you some more about how to deal with that. So this is configuring cipher suite negotiation. So cipher suite negotiation is kind of what we saw. The browser comes to your website and says, I know how to interpret this key exchange mechanism. I know about elliptic curve Diffie-Hellman. I know about Diffie-Hellman. I know about RSA. Okay. Then the server says, I know about elliptic curves, but I don't know about just straight Diffie-Hellman. And so we're going to agree on using that protocol. Okay, so this is the browser and the server are going to try and figure out something that they can both support. Okay? So the browser is going to come through and say, this is the cipher suites I support. The server is going to select one that it agrees on. And if they can't agree on a cipher suite, then the connection is dropped. Okay? And so the question is, what is the cipher suite? And to make a cipher suite, you need to you need to create the symmetric encryption keys. You do that with the public key cryptography, and so you need to exchange keys. So you do that with your key exchange algorithm. Then you need to do bulk encryption, and right now, I think the only bulk encryption algorithm is AES, which is the Advanced Encryption Standard, which was standardized by NIST, I think in 2004. But there's kind of variants of AES now. Then you need a message authentication code, so you won't need to hash it. So you've got this encrypted message. Before you encrypt it, you hash it. You send the encrypted thing, and then you send the message hash to say somebody didn't get in the middle here and mess with our encryption. And then you need an authentication protocol, and so most people say use RSA. So when I sign my certificates, I sign it with an RSA key, And then people go to my website and it shows this little green bar, and they go, okay, since he has this private key which generates the public key and has this certificate chain back to a root authority, then I trust that he is who he says he is. Okay. And so when you want to figure out what ciphers you can put into your Nginx config, this is how you're going to do it. You're going to use OpenSSL to find out all the ciphers, and then since Nginx links against OpenSSL, and I think Apache also links against OpenSSL. We don't know, probably. Yeah, it would be very weird to see that happen. So I'll go here. So to look at that, we're going to go OpenSSL ciphers, and look at all these cipher suites that we have here. Okay, we've got tons of them. I'm going to text replace here. All right. So you can see that there's just this big mess of things that you could potentially support, and it's not clear what any of them mean. So if we want to understand a cipher, we're going to say, let's take one such as elliptic curve Diffie-Hellman with a digital signature. I'll copy that. Okay, so this is saying here, this cipher suite is a TLS12 cipher suite. It uses elliptic curve Diffie-Hellman for the key exchange. It uses RSA to authenticate your identity, and its bulk encryption is AES 256 in Galois counter mode. And then this AEAD means that AES both encrypts and authenticates. It's part of the protocol. Okay. So if you want to see the entire list, I think we can do this. Yeah, so you can see here are the entire list of protocols that you could put in your Nginx conf. Most of them are SSL v3. These are things that you never want to use because SSL v3 is just completely broken. So if we filter those out, we're left with only TLS12 protocols. So actually, I couldn't support TLS11 on my machine, since my OpenSSL does not have any TLS11 protocols. Make sense? All right, so let's see. Maybe we went through that. The order that you put into your SSL ciphers really does matter because you are specifying a preference. So when a browser comes at you with their list of things, you're going to go and see first, does it support elliptic curve Diffie-Hellman with RSA and AES 256 in Galois counter mode with a SHA-384 hash? If that's the case, then you're going to use that one. If it doesn't, then you're going to use this one. Okay? And you're going to say, prefer my ciphers to the browser ciphers, because the browser will come in and say, I prefer this. And if you don't tell it what to prefer, the browser is going to come at you with some weak stuff, and it's going to try and basically a theme of this talk later on is how basically nobody goes after strong crypto. They're going to try and downgrade your protocol. They're going to try to negotiate a cipher suite that they know to be weak, and then once they negotiate a weak cipher suite, they just crack it. Okay.
When you say negotiate cipher, you're saying that that SSL that you ran before, it will try to handshake with everything.
Yeah.
And when it figures out that you're using the weak one, it will try to break that.
Yeah, that's right. That's right. So you might want to know what cipher suites your browser supports as well. That's kind of interesting. So I did this for Google Chrome, and Google Chrome shows me that I support elliptic curve Diffie-Hellman key exchange with elliptic curve digital signature algorithm and cha-cha 20, which I've never heard of before. So you can go through and see basically how your cipher suite matches up with a browser you want to support. Okay. So I'm going to get on my my bandwagon here, which is that you should prefer these Galois counter modes, and you actually have to move to SHA-256 here. Google is doing this big push where they're saying any certificate signed with SHA-1 is now going to not be trusted. So you must sign with SHA-256 or SHA-384, and pretty soon it's going to get so that they won't even allow clients to make the connection to your server. All right. Also, the elliptic curve cryptography is much stronger per key length bit than the older sorts of just discrete log RSA factorization cryptography. And so you should probably use those for your server load. It'll make it much faster. Unless you think the NSA has a quantum computer, in which case you're pretty much screwed anyway, but not as screwed. And so just to show you, let's take a look at this Nginx configuration file here. So let's see what we've gone through. So SSL protocols, it supports TLS 1.2. Prefer the server ciphers? Yes. Then go through and say what server ciphers you want. And here is saying, these are the cipher suites that I don't want. And somebody's got to, maybe someone who knows more than me can explain why I need to put this in here. I thought I explicitly authorized the crypto systems here, but it seems like we're putting in some things to say never attach via these. And this seems to be a standard configuration. I would think that maybe I wouldn't have to put this in here. Like, this basically says, oh, I don't want any export grade cipher suites. I will not connect to a browser that wants to connect to me using an export grade cipher suite. I will not connect to a browser that wants me to use MD5 for hashing the message. Okay? But I don't know. We'll find out. All right, so that is, thus far, that's how our Nginx configuration is looking. Okay. Now, I want to talk about some specific attacks against TLS 1.2 because TLS 1.2 actually has some vulnerabilities that make it so that you could lose a lot of money really fast. So there's a new attack that was discovered relatively recently called a Logjam attack. I actually read about this attack in Bruce Schneier's book written in 1994. There was a big debate over Diffie-Hellman key exchange, and they said, oh, in Diffie-Hellman key exchange is too weak, and if we had a pretty damn nice computer, at the time it was, not a computer they could build, but they said if we had a nice one, we could do this lookup table and then crack all these people. So turns out that the NSA probably was doing that. And so I want to go over Diffie-Hellman key exchange. So when you do a key exchange, this is for your public key crypto system, and then you're trying to exchange your symmetric key. So you're going to pick a prime P, and then you're going to pick a number G, which is less than P. So you're going to generate, G is going to have to generate a subgroup. And then you're going to pick a random number A, and you're going to keep A secret, and you're going to publicize the prime and the group generator. Okay? And then you're going to transfer G to the A mod P, and you're going to cryptographically sign the prime, the group generator, and the message. Okay? Now, the client, with his browser, chooses a random number B, which is less than P, and he's going to send the server back B, okay? And then the secret is just you're going to do another modular exponentiation, okay? And modular exponentiation is fast, right? If you have a exponentiation by repeated squaring, I think if you have 512 bits, it takes 512 exponentiations to compute a modular exponentiation. However, the only known way to do a discrete logarithm, which is, if you're going to try and solve this equation for a, that's called computing a discrete logarithm. Computing discrete logarithms, the current best known algorithm is called the number field sev, which is exponential time algorithm. And basically what's happening is that you're trying to figure out what a solves this equation, but since it's wrapping over, it's really hard to figure out what number to pick. Okay, so this is basically clock arithmetic, right? All right, so I wanted to diverge you onto this concept called forward secrecy, which is, let's say that somebody comes to you and says, we want your RSA key. And you say no, and then they say, here's a warrant. Well, at that point, if you're using RSA as a key exchange protocol, then everything that you've done over the past, everything that your server has served is now broken. Because you can immediately de-encrypt, you can create all the session keys, and then if you were listening, if somebody was listening into that communication, they can go and break all that traffic. However, Diffie-Hellman key exchange doesn't have that property, because when I pick this random A, I use a random number generator to get it, and then it stays in RAM, it never goes to disk, and then at the end of the transfer of the public key, I throw it away, right? So if somebody comes to you with a warrant and says, I want your random A from your Diffie-Hellman key exchange, you say, sorry, it's gone. So basically, when, and not only that, but not just a warrant, if somebody breaks into your server and finds your key, then all your traffic is now broken. Okay, so when I am doing this sort of key exchange on the server ciphers, I'm always using Diffie-Hellman, elliptic curve Diffie-Hellman. And so you can see in my nginx.conf, elliptic curve Diffie-Hellman, elliptic curve Diffie-Hellman, and Diffie-Hellman exchange. So Diffie-Hellman makes it so that it has forward secrecy. Okay, the keys from your long-term public keys, if they leak out, it's not going to de-encrypt past communications. Okay. All right. So here's, going back to the Logjam attack, here's the question. What if it takes 2 minutes to generate a prime? Takes 2 minutes, right? You know how to do primality testing. You divide it by the first 2,000 primes. And then after the first 2,000 primes, then you do Miller-Rabin primality testing. And then you, after, you compute for 2 or 3 minutes, you say, this is like 99.99% certain to be a prime. Okay. So it takes a couple minutes to generate a prime for your key exchange. Okay. So if anybody says, well, I don't have time to do key exchange, I'm not going to generate a strong prime, everybody's going to use the same prime. And so what you found out is that 92% of Apache servers were using the same prime. Yeah. So basically, once you support these 20-year-old browsers, then you have to support 512-bit primes. Okay? You support 512-bit primes, and everybody uses the same 512-bit prime. That allows a very determined attacker to create a lookup table. And so they're going to pre-compute on GPUs for about 2 or 3 weeks, and they know that 92% of all web servers are using the same prime, and after they do that, they're going to break all your communications in 90 seconds. So basically, they're going to do a man-in-the-middle attack, downgrade it so that you're supporting these 512-bit export-grade protocols. Then, if your browser supports it, if your server supports these 512-bit protocols, then all your communication is broken. Okay? So basically, the fixed cost is a week of computing on very expensive hardware. The marginal cost of breaking this is 90 seconds. Okay? So there is a very easy solution, which is generate a huge, large, unique Diffie-Hellman prime for key exchange. Okay? And then you're going to add it to your nginx.conf, which is, here's my Diffie-Hellman parameter, and it's this PEM file. So I can show you really quick, which is, this is going to take a long time. So OpenSSL, Diffie-Hellman param minus out, foo.pem, and I used 4096-bit primes for my server, but as you can see, basically what this is going to do, this is going to take a long time. So what it's going through here is it generates a random number, and it says, is this guy prime? If we test it and find out it's not, then we got to restart. Okay. So we're getting all these restarts. We're looking for primes. It's not going to be very hard because the probability of finding if you take a random number that's 512 bits long, then the probability that it's prime is like 1 in 512. So there's a pretty high chance that we're going to get a prime if we just keep on looking around for a while. But still, when you're generating this prime, it's time to take a coffee break. Okay, and I won't do that. I won't finish this computation because I already have my primes. Let's see. Where am I? I already have my primes over here. Where is it? Oh, there it is. This is my prime that I generated, and you can see the this is my 2048-bit prime here. Okay. All right, so once we generate this huge prime and we're using strong Diffie-Hellman key exchange that's forward secret, then SSL Labs will be very happy with you. Okay? They say, we don't know of any exploits against this, and so we're going to give you an A. That makes your customers pretty happy, but there's still things that people can do to you to make you very unhappy. Okay? So I want to talk about this concept known as strict transport security. And there is a really nasty attack if you don't set this strict transport security header. And I'll describe that to you. This will make you scared to go on the internet. But so basically, when you are engaging in strict transport security, what you're saying is, this server serves everything it serves over HTTPS. If you get anything from this server that's over HTTP, that's a man-in-the-middle attack. Okay? And so you've got to send in the HTTP header, you've got to say, I'm using everything in HTTPS. If you don't do that, people can get in the middle. They're going to send garbage, just total garbage, to your browser, and your browser is going to respond with the one unencrypted thing, right? Your browser will send a credit card number unencrypted, right? If the server says send it unencrypted and you're dumb enough to send it, it'll do it. If somebody gets in the middle of your session and says send me a credit card number unencrypted, and your browser doesn't know that everything that your server is doing needs to be coming over HTTPS, they'll take it. And actually, there's this guy named Moxie Marlinspike, I think his name. Yeah, he has written great software to do this for you. You can strip, here it is. I'm going to strip off the SSL off of these transactions, and yeah, I love this thing because it's just used for criminals. He's got it posted on his website. All the criminals can come. Here's how you steal everybody's credit card numbers. Oh, and there's a bug report. Oh man, bug fix. Oh, we weren't stealing people's stuff most, efficiently. Yeah, fixed a minor bug that could prevent favicon spoofing from working. Oh man, that's terrible. So yeah, it's not hard for people to do this. They've got packages where they can just go on the internet and start stealing people's stuff. They don't need to write the code themselves. And this Moxie Marlinspike guy, he's pretty smart. So when he says he's done it, I haven't tried this. Maybe somebody can report back to me secretly as whether they've managed to steal some session keys with it. But
You can just take your laptop to DEF CON and everything will
yeah,
take care of
that's right. All right, so I will show you how to get past this attack, which is you're going to set an HTTP header that says everything's going to come over HTTPS. And now when I go, so what I did here is I opened up Chrome, and then I served my website over HTTP. And since I had previously set this header, Chrome had set a cookie saying whenever I go to Nick's stupid website, it's going to be coming over HTTPS. And so Chrome has this warning message which says, Jeremiah Cornsticks normally uses encryption to protect your information, but the website sent back unusual and incorrect credentials, so somebody's trying to pretend to be Jeremiah Cornsticks. Okay? And so you cannot visit Jeremiah Cornsticks because the website uses HSTS. So it's saying somebody's in the middle, somebody's attacking this. You can't go there. Now what I found out is that if I clear my browser cache, then I can get past it. But but I think you would have to be pretty bold to clear your browser cache to get past that error message. That would scare me. But who knows? So basically when you say, all right, everything is going to be over HTTPS, the first time the browser visits there, then it's going to set the cookie. But if you want it so that first-time users can't be victim to this either, you can register your website in the preload list where it says everything coming over this site is HTTPS. Okay. And the preload list takes a while. Basically, if you think that you will ever serve over HTTP again, don't put your site in the preload list, because at that point, Google Chrome will distrust your site for the rest of time. So don't do it. Now, to configure your HSTS, we're going to add this to the default file in the Nginx configuration, which is add header, strict transport security, and this is max age parameter here. The max age says I'm going to be serving everything over HTTPS for the next 63 million seconds, and everything in my subdomains will also be HTTPS. So the browser is going to come there, it's going to say, oh, for the next half a year or so, this is going to be HTTPS, and therefore I will remember that. Okay. And you can also configure this in Django Secure as well. So you just add this to your settings.py. So your HTTP strict transport security, this is how long I want it to go. I want it to include the subdomains. This HSTS is communicated via HTTP headers, and Nginx just doesn't care if you put syntax errors in it, in its configuration file. So if if you're configuring this, I actually did this a number of times. I configured it and then started it running, but I put it in the wrong section, and so it didn't actually set the header. So I've got this browser extension, which I think is kind of neat. You guys can see if you agree. It's called Live HTTP Headers. So I'm going to go to my website, and I'm going to reload it. And I did a git status code 200 here. And if you look at it, let's see what headers I got. I got strict transport security, max age 63072 million, includes subdomains. So you should actually go in and verify that when you put something in your Nginx header, in your Nginx config file, that it actually got there. Because I actually changed Nginx versions as well, and that broke it. So, and there's some other Nginx configurations out there that have these tokens in the file that just do nothing. Okay, so we can look at this default file here, and here in the server section is where I put it. Okay.
Did you say that was only respected by Chrome right now, or is that
No. Actually, it's respected by all major browsers, but not like old browsers. This is a relatively new attack, I think. When was it? 2011? Let's see when the first one. 09. So actually there's a lot of browsers that will not respect this header. Of course, since my server is configured only to serve over TLS 1.2, none of those browsers will be visiting my server. But you know, if you screw up your computer security, you're going to get walked out the door. You know, there's just no doubt about it. And so when I did this, I figured I would rather have our clients bitch about not being able to see our site over their ancient browser than me getting walked out the door. So I decided to do it good. All right. So this live HTTP headers is really quite nice. There's other ways to validate that you've actually set your headers, your HTTP headers. Here's another one, which is Alt-Command-I, but that does a bunch of other things. You can see all sorts of traffic coming in over that using Chrome. And you can use Wireshark as well. I get a little bit intimidated by Wireshark because I don't do this very often. So it kind of brutalizes me. And all right, to get some more points on your SSL lab score, you need 4096-bit RSA keys. I don't think anybody's really afraid of 2048-bit keys getting factored right now, but they've factored 796-bit RSA key, which was pretty intense. So if you want your stuff to be secure for a long time, you need to start using 4096-bit keys. And you're just transferring 256 bits at the end of this, right? So the public key is not the actual limiting factor. You're never going to notice this on your performance. It's going to be very fast. And so to generate your RSA key, you use OpenSSL. All right? And you need to sign it with SHA-256 or greater, or else, as I said, Google Chrome will not trust it, because SHA-1, Google believes that SHA-1 is going to get a hash collision very soon. And what you can do once you get a hash collision, you guys remember the when the Iranian centrifuges got Stuxnet? How do you get Stuxnet on the Iranians' Microsoft Windows computer? You guys know? Huh? Well, I mean, you can transfer it around, but the Microsoft makes sure that every single piece of software that runs on it is digitally signed. And they digitally sign it using MD5, which has been known to be insecure for about 25 years. And so the NSA generated a hash collision on MD5, and then once they had the hash collision, they could load up any software anywhere. saying it was digitally signed by Microsoft. And so this was this rootkit, horrible thing that they generated hash collision. They caused all sorts of chaos in Iran. And I mean, hopefully Microsoft 10 doesn't use MB5 anymore.
Probably does.
Probably does.
Maybe it's clear text now.
Maybe, yeah, that's right.
Might as well
right.
just give it up.
Right, so in any case, don't use SHA-1. People think that any day now there's going to be a hash collision against SHA-1. And once that happens, all hell will break loose. Absolutely all hell will break loose. So, yeah, once you do this, then you have gotten full marks on SSL Labs. I don't know if you care all that much about getting these extra things, but your clients will like it. There's also this thing called OCSP stapling, which is to determine if a certificate has been revoked. So whenever your browser goes to a server, it goes and says, oh, you've got this public key, has the certificate associated with it been revoked, and it goes to the root certificate server. And basically that reveals to the root certificate server who your clients are. Some people don't like that, some people don't care. But in any case, what you can do is that you can have the server digitally sign their certificates and then send the digital signature back to your server and cache it for a little while. And what will happen is that your browser will be much faster. Okay? Basically your handshake. All right? So this is how you do the OCSP stapling, which is that you need to bundle your root and intermediate certificates together. And then since, of course, I bought a $5 certificate from Komodo for this talk, this is the actual command that I use to generate the OCSP stapling certificate. Okay. And then in your Nginx conf, this is actually Google's DNS resolver. And then say, I want SSL stapling, and I want it to verify it, and here's my trusted certificates. Okay. Oh, and I should say, the certificate authorities, they'll just make your eyes bug out of your head if you see the things that are done by various certificate authorities. They're completely corrupt. So there's a new project called Let's Encrypt that is going to be giving out free certificates to everybody. I don't know. It's from the Linux Foundation. I kind of trust them, I think. So I certainly trust them more than any other certificate authority. And I think they're going to give out these free certificates. You won't have to worry about paying for them. And I hope it's very easy to use to get your certificates, because sometimes certificates kind of become a hassle. Yeah. So I want to give a shout out to that. We also need to talk about clickjacking, because this is a nasty attack. I think you know about this. So let's say that somebody renders your page in there. So they say, I've got ebay.com, and I'm going to put it in a little frame. Actually, let me do this before we. I've got a file. I've got a file here. Documents, workspace. This is called. If you're following along with the talk, you can look at this frame.html. Okay, I open it, and I'm basically embedding somebody else's websites in my website. And if we go through here, so if we look at this frame.html, it's basically embedding W3 schools in this iframe. It's embedding marginal revolution in this iframe. And it's embedding proton mail in this iframe. Okay? So if you look at it, W3 schools is embedded, marginal revolution is embedded, but proton mail is not embedded. Right? So basically, the server can say, I do not allow anyone to embed me in an iframe. Okay, and so your browser is now respecting that request. So if I actually go, if I look at SSL Labs, you can actually see this. Well, actually, let me just go to Proton Mail here. If I go to Proton Mail and I do my live HTTP headers, I refresh this page, and you can see, let's see, here's the headers. Where is the original one? Stats, Proton Mail. All right, I thought this was going to be easy, but now I'm just kind of...
You can probably just curl it.
I can curl it?
Just curl it and just do a -v verbose.
A curl verbose on...
Yeah, and then
curl
you
minus
won't
v.
get all the extra.
Like that?
Yeah. And you should get headers.
Yeah, that's actually much nicer than them. Thanks. Let's see what we get here. Host name, found a deal, move permanently. Oh, so I got a 301 because I went to HTTP. Oh man, I gotta pipe it into more.
If you do
Yeah.
a big I on there, it'll do a head request instead of a get.
Oh really? Minus.
Add a
Dash capital
I dash capital.
Oh, minus v minus I.
Yeah.
Okay. Ah yes. So there we go. X-frame options, same origin. So that says I will allow anything from my own website to be embedded in my own website in a frame. But if you try and embed my website in yours, it needs to be denied. Okay. And this attack is pretty nasty. I've known some people that have actually almost fallen for this clickjacking attack. Let's see if I get it. So what they'll do is they'll take eBay.com, they'll put eBay in a iframe, make eBay.com invisible, and then they'll put win a free iPad on top of a button. And then what happens is when you click that win a free iPad button, then it actually goes through to eBay, and if you're logged in, then you've just bought their, trash for like $1 million. It's really not polite to expose your clients to that sort of risk.
There's still old browsers though that probably don't support that header too.
Yeah, that's right. Basically, if you have to support old browsers, somebody's going to get screwed. And it might be you get walked out, and it might be the client that has to just eat it. But either way, somebody's going to get really screwed.
What if you want to serve your website as an iframe? Like for example, like Facebook tabs, they're iframes. So if you want to make a Facebook tab, you have to serve your site as an iframe.
You can probably subdomain that out or something. And just put it on don't serve that from the main site.
Right.
But subdomain it out, run another Nginx instance or something.
And make it just read only.
Yeah, I mean you could.
I mean, yeah, that's one of the problems about like the modern internet is just like, oh, embed this trash and click this button here, and if we get these clicks, we'll get rich, and so we're gonna put layers and layers of trash everywhere, right? And like it's kind of basically one thing I've noticed is that the whole principles of making kind of the client or the kind of consumer-focused websites like Facebook and The Onion and clickhole.com, right? All those things, all their strategies are completely anathema to security, right? They're making money off of just this mess of click-through crap. So I'm not in the situation where I need to support that sort of stuff, fortunately, so I don't. I don't begrudge anybody for having to work for a living doing that, but you're exposing yourself to risk. All right? Oh, and I should also show you. We also need to verify that this header has been found. Let's see if I can reload it. Oh my god. Header.
By default, it's always same origin, right? That restriction's always there.
Same origin?
Oh yeah, on the Django site.
Yeah.
On a Django site, yeah. Yeah, a Django site will put middleware to basically set the same origin. I set it to deny because I didn't really know of any application for it, so but yeah, anyway, okay, this is one of basically clickjacking was used to take over your computer's microphone and camera. So basically people were able to watch other people do their own daily lives. They probably learned nothing of interest, but it still scares people. And here's your defense a bit against clickjacking. If you're basically, doing your normal business, you're not going to go through the HTML and read if there's iframes that are embedding other shit in it, because there will be iframes that are embedding other shit in it. So you're just screwed.
So you're gonna pay attention to the certain domain, right?
Oh, come on. Nobody looks at the certificate authorities. Nobody's ever
Well,
done
I mean, mom and dad maybe not, but I would hope that you would pay attention to that.
I have looked at certificate authorities, but I've never been in the case where it takes some presence of mind to be like, wait, something's wrong here, and I'm going to check the certificate authority, and I'm going to check for an iframe. It's kind of very difficult to be a web user and defend yourself against this stuff. And, I should also tell you guys may think, I'm just serving this read-only website that doesn't take payment information, it doesn't take user cookies. Go read about packet injection. Basically, if you have an unencrypted website, somebody can put any packet they want in the middle of that. There's nice little APIs to do packet injection, and they can do whatever. All right, anything that the browser will allow in a script, they can inject as a packet. So just encrypt your whole thing. It costs like 1% server overhead, is what they found, so it's not that much.
So you should just think, I'm just building a blog for myself to talk about, talking about my cats. And
Yeah.
You still need to encrypt that because packet encryption will eat your lunch.
Yeah. Well, it won't eat yours, it'll eat your users, right? They're not injecting onto your server, they're injecting onto the browser.
I've seen hotel Wi-Fi put ads and things like that.
Yeah.
Not ads that the site server, but ads that they're routing.
Southwest does that. On their Wi-Fi, they inject, if it's not encrypted, they inject their JavaScript into every page.
Yeah. Yeah.
You were saying that your recommendation that you were making so far, all of that together is like 1% overhead.
Yeah.
Yeah, it's not much.
It's nothing. Yeah.
You can still serve up like 5-10 millisecond requests on SSL.
Yeah.
Site.
And when you have the handshake is actually this part where you might notice it is that when they do the cipher suite negotiation and then they do the public key protocol, you'll kind of notice that get a little bit slower. But what you do is you set your SSL session timeout to in maybe 30 minutes or something. Then they have that one-time expense of doing the cipher suite negotiation and the symmetric key transfer. Once they do that, the bulk encryption is nothing. The bulk encryption is so fast. And actually, that's why AES was chosen as the NIST standard for bulk encryption. It's because it can be done being used, basically since it's in the Galois field, 0-1, it can be done using bitwise operations the whole way. So there doesn't need to be any sort, it's just hardware, XORs and not. So it's super fast. And anyway, to basically, as I was saying, Nginx and Django Secure have kind of the same sort of functionality. So you can put those either either you can set the header in your Django project, or you can set it in Nginx, or you can set it in Apache, actually, if you're using Apache. And this will be deprecated fairly soon. There's a new kind of systematic way of dealing with this called content security policies, but not many browsers use it, so I'll leave that for later. And the clickjacking was so huge that, as you were saying, by default this header is set in the HTTP response. Okay. All right, and I'm basically showing how to verify that this thing was actually there. Okay, and then this is getting into some more marginal stuff. We'll probably stop fairly soon here, but this content sniffing, basically, there's no like compile error in HTML, right? In C++, if you make a syntax error, it's all done, right? You cannot move on. But in HTML, it basically tries to do whatever it can to display a page to the user, even though it could have horrible syntax errors. And so one thing that happened is that a lot of HTML was being served without, basically it might have been a JPEG, but this browser didn't know it was a JPEG, so it tried to figure out what the content type was. So, oh, is this a JPEG? Is this or that? And so Microsoft gave Internet Explorer the capacity to try and guess the interpretation of various types of content. Okay? And that algorithm is really bad. So basically by using these bugs in the content sniffer, they can be deceived about what sort of things they're downloading. So this is really a problem if you have users that upload data and download data. So maybe if you're running a torrent site, somebody will push something that's labeled as a JPEG or has like the first few bytes of the JPEG. They take it down and it's actually a script. So what you do to do that, to get rid of that, is you say, don't sniff my content. As a user, maybe you're pretty much screwed if you use Internet Explorer, because, I mean, you're not going to look at everything, right? You're not going to go and interpret your own data. And then here's the way to do it in Django Secure, is just set that. Okay. And then once you do that, you'll see that HTTP header coming through. And so again, verify that that HTTP header came through, or else maybe you add this in the wrong spot. Okay. All right. And I think this is actually the last attack that I want to talk about. This is for people who have stuff that's actually valuable. So, like, not me. Like, none of my none of the data. It's valuable to my clients, but it's not valuable to the entire globe, right? So let's say that your Gmail has a bunch of people's data on it that might be very valuable to some negotiations. So what happens if 2 certificate authorities issue certificates for gmail.com? Yeah, that's exactly right. So this has happened numerous times, which the Iranian Certificate Authority is notorious for issuing certificates for various websites that they think they might benefit from hijacking. They also hacked into, once they got their trust revoked, they hacked into the Dutch Certificate Authority and had it issue certificates for about 1 billion websites that they wanted to take a look at. And then that Dutch Certificate Authority got its trust revoked. And then they hacked into Komodo, and then they issued certificates for a bunch of stuff that they wanted to hack. So you can read, these are links to various articles about how the Iranian government has been really playing around with the certificate authority. Basically, nobody looks through the certificate chain, right? If you get a little green bar, you're happy. It's better than 99% of the internet, right? You don't even get a green bar on most parts of the internet, so you're like, well, whatever. I don't know what certificate authority most of the websites I use come from, so if it changes one day, I have no clue. So the way you can mitigate this on the server side is to do what's called public key pinning. So basically, you tell your browser to remember what the public keys were for your website and to trust what it received the first time it came. So it's called trust on first use. So if a first-time user comes to your website and a rogue certificate authority has issued a certificate and done a man-in-the-middle attack, then yeah, they're screwed, but most of the time they don't have much data. If it's the first time they've come to a website, they don't have much data on it anyway, right? So it's not a big issue. So it's actually a fairly robust solution. I don't think it'll be the long-term solution. I think probably in TLS 1.3 they'll figure out something better. But for now, you do these hashes of your public keys, okay? And so the way that you do that is you take OpenSSL and you take in, oh, did I miss a slide here? Oh, I'm sorry, I think I missed a slide here. Yeah, I should have put your regular key here. So what you do is you take in your regular key and you output it in binary. OpenSSL regards this form dir as a binary, and then you want to take the public part of that key out. Then you generate a SHA-256 digest in binary, and you re-encode it in base 64. So this is how you do the public key pinning. And then in Nginx, you're going to put this header in it. And one thing that I should have said is that you need to do this, you actually need to create two private keys. You have your server's private key, which you hash using this method. And then you add this header in here. But what happens if your server gets compromised? You've told the browsers to remember the hash of your public key, right? And so they're going to remember that you had this particular key, but it's been compromised, so you had to delete it, so then they can't come to your website anymore. So what you have to do is you have to hash two keys. Apparently you've got to have two different secure servers, hash those keys, and then if this one gets compromised, then the browser will still trust that one. Okay, and this here is a typo. This is the timeout on this protocol. I actually put that in there because I didn't want to. I actually wanted to test that I got the hash right, and I didn't want my browser to not trust my own website for the next million years, so I set it to 0. This is wrong. You need to put in something. This is measured in seconds. Put in like a year or something. Okay. Oh yeah.
How would you handle when you have to renew your certificate with that?
Well, you renew your certificate with your private key, right?
I guess you could.
Yeah, you can use the same private key for new certificate requests. And you can kind of cycle these out with time, right? If you know your timeout for a certificate request is, if you set it to like a month, you could swap one out to the other, and you know that you got to wait 30 days before you swap again. Right? And let me see if I have anything else here. I think that we're pretty much good on this. So if we want to just if you want to see anything else, just ask me. But that's all I had.
Can I ask a question?
Oh yeah, sure.
So what I'm taking from this talk is that there is security if you're a website owner. There is security if you're a website user, and then you can look at security as a website owner who wants to protect his users, right?
Yeah.
So let's say I created the website that has the payment processing on it. So what are the steps that I need to do to protect my website and my users? And if I could do that by, if I could improve my security by eliminating some browsers and some versions of browsers,
Yeah.
what would be the best choice?
So actually,
Kind of practical question.
yeah, so basically you will, as I said, you can look at SSL Labs. I hope it's still cached here. My Jeremiah Cornsticks bullshit. Fortunately it was cached. So if you look here, if you turn on TLS 1.2 and turn off everything else, then you will lose all these. You'll lose Android 2.3.4.0. You'll lose Baidu. You'll lose IE 6, 7, 8 through 10. You'll still retain IE 11. And you'll lose all Java clients and old versions of OpenSSL, early Safaris, but the rest will be safe. And actually, to take payment cards, you have to do this. And that's going to be mandatory as of next year.
So what are they planning on doing for that? I mean, that's
Just telling everybody to fuck off, man. That's so they're going to revoke people's PCI certification statuses. It's pretty heavy, especially since Windows was like so behind the ball on this, right?
they're just trying to force everybody to
Yeah.
to get up to speed.
Yeah.
They probably just got tired of it.
Yeah.
Of that list, are the IE ones the most recent?
So
Like,
yeah, so
is IE 10 the most recent browser on that list? It's good.
11.
IE 11,
Yeah.
is the most recent that will work.
10, a lot of people are going to have 9, 10 installed though.
Oh, yeah,
I
totally.
think 9 is
Yeah.
when it started auto-updating now, so that helps.
I was about to say it goes through the second.
There's still a lot of people.
Yeah.
Yeah.
It just depends on
I think
how they
they
handle
changed
their
the-
software updates
Yeah.
in-house. Because
So-
you can disable that auto update.
Yeah.
Is Microsoft pushing? They pushed the Windows 10 bit this week, but are they? Yeah, they're not going to remove the ability for 7 because like 8 ships with IE 11.
Yeah.
So
Yeah.
I think 7 can. I know you can get 10 on 7. I don't know about 11.
Oh,
Yeah,
you
I
can.
don't
You
know.
Can you? Okay.
But Edge.
Edge.
I'd
I don't
say-
know.
Have you seen that?
Actually,
I'd
there
say
is
for
that a
him it's
browser?
Statistical, right?
That's the new
What?
Microsoft browser.
Yeah.
For his question, it's statistical. Like,
Yeah.
I mean, they don't throw the stats or the date up there, but it would actually be nice if they showed a date on when the Android release was.
Right.
Because
Yeah,
that's
yeah,
what,
yeah,
like,
yeah.
just
No,
statistically, you just got to figure out how many users are on 4.4, whatever.
When we look at our stats, like we've got, some 7s and 8s, and then almost no 9s or 10s, but then it picks up an 11.
Yeah,
It's kind of weird.
Google Analytics will
Yeah.
give you the best. Like, I mean, if you run it for a couple of months,
Yeah,
it'll give you
there
the
are two
best
approaches.
outcome.
There is an approach that you go and see what browsers you want to support, and then based on that you decide what's the maximum security, right?
right.
And then there is the other approach. You say, okay, I want maximum security.
Yeah.
And so, what is available there is maximum security. Apparently, you're losing a lot of Android stuff.
Yeah.
Well, are you
Right.
handling the transactions yourself, or are you outsourcing it to somebody else? You're not storing credit card information, right?
No, I'm not. But,
Right, but I
you
don't
want
know.
to
They would have
protect the
to.
content of your website as well.
Do you know if the PCI compliance stuff actually, if you have something that's transactional, that you inherit the TLS 1.2 as a factor of? Because I think generally
I
right
think it would
now-
probably be your server to card processor, right? That's where the handshakes
'cause
will happen.
You would screw Stripe if that was the case.
Yeah.
'cause
Yeah, that's
Yeah,
right.
but all that handshake
Stripe
is happening on the
Stripe
back end.
handles the PCI compliance side of things.
Right.
All the stuff is happening from Stripe is happening on your server, so
Yeah.
that's where you would have to verify.
I'm actually curious if that hits the server that's actually, it's relevant for us at Pi Texas, right? Because we use Stripe, so it's,
Yeah, so but all that is happening in the Python code on the back end. So like that's not like happening in the web browser,
Yeah.
right? So that's all just Python talking to Stripe.
Right. And actually, here's the browser versions and the TLS protocols it supports. So Google Chrome had really early TLS 1.2 on Windows, and that's on the 30 through 32. After that, it's done. So this Wikipedia page will tell you, I think, the answer to your question.
Which page?
This is TLS, Transport Layer Security.
Oh.
And actually, it's linked in the talk here. It's almost no browser support. So.
What about Jason? When you have an API,
Yeah.
does all this stuff apply there too? Like, would you add all that those more security on a JSON API? Or?
I would probably apply. I mean, yeah, I would say yes.
Yeah.
Actually, you're gonna have another header for that you're gonna have to worry about, the cross origin headers.
Right.
Right.
So it's just kind of like the X-frame, but for JSON APIs.
Right.
But yeah, I think a lot of this. I mean, it depends on your API, right?
Yeah, generally you read origin. If they'll send, browsers will send origin, or most people will have origin in the headers that they send you, and then you have to check within a list of whitelisted domains that are allowed to actually access your API to any kind of AJAX call from your browser. That's how you handle that. And if they don't have an origin header, then you should pump them. Like, I'm sorry, you don't have access. Period.
Well, again, it depends on what you're using your API.
Yeah, if it's internal, then maybe.
Yeah, if you just want people to use it for from your website, yeah, check the origin.
Right.
Yeah. Like Twitter wants everyone to download their data, right? So we're allowing all origins.
So Kojo, I think you had a question.
So maybe I missed this earlier, but I saw you talking about changes in the HTS config file, and also doing things in the Django settings file, like Django secure.
Yeah.
Do you use this in both places?
Yeah. So the thing is that Nginx is exclusively responsible for cipher suite negotiation, but it can also set those HTTP headers. Django Secure can only set HTTP headers. Okay.
But you'll get duplicated.
Yeah,
you'll get duplicated. It's a mess. It'll be confusing to use them both at once.
So you should not be using them both together.
Yeah, don't use them at the same time.
You just got to make sure that your Nginx config actually handles it if you're going to take it out of Django.
Yeah.
And leave it in the hands of Nginx. So, I mean, as long as you got a config that you trust, that you can float around with your change server or whatever. If you're in configuration management, you should be set. You just got to know what's, and that easy thing is checking with curl, right? If you got more than one header in there,
Yeah.
then you should you figure out who's setting the duplicate and either move it over or get rid of one or the other.
Right.
What was the component you talked about at the beginning? It was Nginx, but it was something else that went with Nginx. Something. Unicorn?
Oh, Green Unicorn, yeah. I'll show you. Green Unicorn isn't providing any sort of security. It's just to serve a Python website.
Oh, okay.
So basically, to do that, you do your deployment, you listen here, and then you proxy pass. So Nginx will listen and then proxy to Green Unicorn.
Is this better than
The what?
MicroWhiz.
Oh, I think they're about the same thing, aren't they? I don't know.
Supposedly, MicroWhiz is a lot faster
Okay.
than Green Unicorn, but
That was the only thing that I saw that was different when I was researching it.
Oh, really?
Faster.
there's some nice things about the command. I mean, the fact that MicroWhiz is just a binary that you run, and you can move it and place it wherever you want to once it's compiled. So
Yeah.
it's kind of nice from a configuration management standpoint because you just deploy the binary.
Yeah. Yeah, I don't know. I'm sure you could use both. Just proxy to whatever micro-WYSI is serving on, right?
So also, if you don't want to have to go through all this stuff, one easy way to get around it is cloudflare.com, which they'll basically, it sits in front of your site, and you can configure all your SSL and everything through them, and they'll handle that. I don't know.
Is that what you do with my Texas? Right?
No. Actually, I didn't. I actually don't like Cloudflare too much.
But you're recommending it to all?
Well, so it's a really good service, but basically they get, because of their their service, what they do of security and DDoS protection.
Yeah.
Everyone in the world attacks them. So, if you want
So
to
they
get
probably
into
know quite a bit.
So if you want to get into a data center that everyone attacks, that's where to go.
Yeah.
But yeah, they have a pretty good service. So if you don't want to think about it at all, you just set up. They proxy to your site, and they do all the security. And I even think they give you a free SSL. I think now.
And because of that, do you feel some overhead of their service?
Well, yeah. So they have all kinds of options because they do DDoS protection and stuff, and so they'll actually even have caching options. So if your site goes down, they'll cache your site for you. But yeah, there is some overhead because they're sitting in front of you, protecting you. So
There's overhead to all that stuff because
yeah.
I mean, on PCI compliance, it's not just SSL, right?
Yeah.
It's also deep packet inspection and the whole 9 yards.
Right, and another thing, as I said earlier, to get through a rigorous IT audit, they're going to ask you whose access. Do you have server logs? Do you have rootkit detection on your machine? Do you have password policies? This is just this is the easy part, right? Another thing that I've found to be very difficult is you've got this website set up and you've got multiple customers that all have data, right? They can authenticate onto your website. How do you keep them from moving sideways once they're authenticated and getting other users' data, right? That's something that is very specific to your model, right? You've got a data model. So you've got to write that code yourself, and that's very risky, right? What we just did here, Nginx has already written all that code. You just got to use it. So you're still pretty far away from a secure website here.
And also the easier, more obvious stuff, at least you're taking care of that.
Yeah. I mean, basically what we've done tonight, we just locked the front door. We maybe put a deadbolt there too, right? So now they'll start throwing rocks through the windows.
I believe too, I think Google gives you a bump in SEO too if you use SSL.
Yeah.
I think they just said they were going to start doing that.
So it's definitely headed that way.
Yep.
Where are your slides? Is your presentation available?
Yeah, it's on my GitHub. So you just go to N.A. Thompson. Oh my God, that's not a repo. I wasn't searching. I'll just sign in. Screw it. Oh, okay. Now I got to get rid of that. Where am I? Oh no.
Just go to your profile.
Profile. Where's my profile?
Oh,
Oh my God.
Yeah, right there.
I don't even know what's going on here. All right, here it is. Yeah. Django HTTPS. And it's got the Nginx conf and the default, which is loaded by the Nginx conf.
Where's your private cert?
Where's my private cert?
I'm just playing. I'm just playing.
Actually, I put that up on my Google Cloud instance. You can steal it if you want. I'm gonna take this website down tomorrow. So.
Why? It's the most secure hello world
Yeah, it's the only secure hello world on the entire internet.